Ujjal sir, are you there?
Yes, sir. Am I audible, sir?
Okay, sir.
Yes. Sir, please, 1 hour video. Please, sir. Hello.
Ujjal sir,
Yes, sir. Am I
Sir, shall we
audible?
start or wait?
Yes, yes. You start now. Sir, for video for our side, you please switch on.
Pardon, sir?
Sir, this video camera.
Okay, okay. All participants requested to switch on the video.
Please allow video from our side. Sir.
Okay, okay. So, good afternoon to all the respected dignitaries, resource persons, faculty members, participants, and students. So, we are on the second day of the 5-day hybrid faculty development program on AI and ML based healthcare research, tools, strengths, and challenges in intelligent medical systems, which is jointly organized by NIT Manipur and Jyoti Engineering College, Kerala. So today we have two sessions. First session is handled by Mr. Jitin Kesi, who is Assistant Professor of Jyoti Engineering College. And the second session will be handled by Dr. Sajida A.S. She is also from Jyoti Engineering College. And now over to our MOC Madam Reshma. Please, Madam. Reshma, Madam. Okay.
Yes, sir.
So good afternoon to all the respected dignitaries, resource persons, faculty members, participants, and students. So we are on the second day of the 5-day development faculty development program on AI and ML-based healthcare research, tools, strengths, and challenges in Indian medical systems. Reshma, Madam, please go on. Madam, please take your sound.
Good afternoon, everyone. A warm welcome to all participants for today's FDP session. I sincerely welcome each one of you and hope today's session will be both informative and engaging. This session focuses on AI/ML in intelligent healthcare systems, tools, trends, and robotic applications. We are delighted to have with us today an experienced resource person, Mr. Jitin Kesi, Assistant Professor in the Department of Artificial Intelligence and Data Science at Jyoti Engineering College, Cherudiruthi. Mr. Jitin Kesi holds both MTech and BTech degrees in computer science and engineering. He is a recipient of the Institute of Scholar Young Researcher Award 2021 and is also a member of NVIDIA Developer Program. He actively contributes to the research community as a reviewer for IEEE Access with expertise in cutting-edge areas such as explainable AI and cyber attack detection robotics. He has also served as an editor for the book Intelligent Security Systems, Data Privacy, Cryptography, and Cyber Protection. His research contributions include publications in reputed platforms like IEEE, Explore, Elsevier, and Springer, covering domains such as AI security, cryptography, IoT security, and optimization algorithms. With his rich academic and research experience, we are confident that today's session will be highly informative and insightful. Let us warmly welcome Mr. Jatin Casey. Sir, you can start the session now.
Thank you, ma'am. Thank you for the introduction. Okay, shall we start?
Mr. Jatin Casey.
Okay, I will share my screen. Okay. I'm visible.
Yes, visible.
Yeah. Okay. So let's start. I'm Jirin Casey, Assistant Professor, Department of Artificial Intelligence and Data Science, Jyoti Engineering College, Thrissur, Kerala, India. Okay. So today I'm handling the topic AML in Intelligent Healthcare System, Tools, Trends, and Robotics Application. Okay. So over this course, we are going to explore mainly on the three broad themes. First, we going for the basic concepts in automations and robotics, just like that. Then we go for the healthcare application tools and trends, and the last we discuss all these how to use and create better application using AI. Okay. So first, let's start with basic automation and robotics. So automation, the use of technology to perform with minimal human intervention tasks. It can be a software-based, just like Excel macro or hardware-based. And robotics is another branch. It can use we can use robotics for multiple tasks. If automation plus robotic physical machine involved, then it can be a robotics application. Okay. So automation is the brain and robotics is the brain with body. Okay. Robotic system does not just execute the program in isolation. It physically interact with its environment based on the real-time data. Okay. Joseph Angelberger, widely regarded as the father of robotics, and the Unimate, the first industrial robot ever deployed in the real world settings. Angelberg, co-founder Unimation. Okay, so he's known as the father of robotics. Before we are going to applications of robotics or any robotic system, we are also focusing on the Isaac Asimov's laws. Okay, here we have the three laws focusing to develop or create a robotic system. We have to follow these three rules. Okay, and the first one, a robot may not injure a human being or through inaction allow a human being to come to harm. This is the most fundamental law. Robot safety comes first. A robot must never be a direct or indirect cause of harm to a human. And the second law, robot must obey order given to it by human being, except where such orders would conflict with the first law. Okay. In other words, robots must follow instruction but not blindly. If obeying a command would hurt someone, the robot must refuse. And the third law says that a robot must protect its own existence as long as such protection does not conflict with the first and second law. Self-prevention is important, but only when it compromise human safety or the ability to follow legitimate commands. These laws may have oriented in a fiction, but they are the philosophical foundation of modern robot safety engineering. When we design surgical robots, or autonomous hospital delivery system. The principle embedded in the software and the pollution avoidance system and emergency stop mechanism all echo these very laws. Okay. And Asimov himself later felt that originally three laws had a gap. What happens protecting one individual might cause to harm many others. To address this, he introduced what he called the zeroth law. Okay, a law for all others. The zeroth law states that a robot may not harm humanity or by inaction allow humanity to come to harm. Okay, this is significant philosophical upgrade where the originally first law protects individual humans, zeroth law protects humanity as a collective. Okay? The zeroth law prioritizes the welfare of the whole over the welfare of the individual. Okay, Asimov introduced this is in later robotic stories when robots become advanced enough to make major judgments about the welfare of humans. Okay. Then you can see thus different types of robots. You may be familiar with that different types of robot in underwater and industrial and agriculture, also in space and healthcare systems. Okay. Before we are moving to the simulation or the robotics tools, we have to know the basic architecture or basic device. It's called manipulator. Manipulator is a robotic arm reprogrammer and multifunctional mechanical device responsible for moving material parts, object, or tools through the programmed motion in a performed various tasks. Okay, this is a basic. Any robot we can take. This is a basic function or device to use to control or perform the task of robot. Okay, this manipulator is used to use the manipulator used for performing the action any robot can take. For example, we can create a picking robot, delivery robots, or medicine picking robot. Whatever we are creating, we have to the basic device is used for this manipulator arm. Okay, this manipulator arm is control everything or performing the end task. Okay, this is the basic structure and join links. What are the function or the components that in the manipulator arm? If you are going to create a simulation software, we have to know what are the functioning or what are the components or join links, what are the components are included in the robotic device. So that means we can use that parameters to develop or create a simulation software simulation of a robotic system. Okay. So these are the robotic parameter we have to know. Degree of freedom, and degree of freedom means the number of access the robot can access, and the working envelope, the region of space, kinematics, payload, speed, acceleration, accuracy, etc. Okay. So before we are going to the simulation software, we have to know what are these what are the parameters used into developing a robotic system. Okay. So we are moving to the healthcare robots. Okay. What are the healthcare robots are now currently used in our hospitals? Okay, and the first one of the important one is Da Vinci surgical system. Okay, so the Da Vinci surgical system is a surgeon control designed system. It is for minimally invasive procedure, enhancing the precision, flexibility, and control. It is the key feature is 3 high definition vision with fine-tuned, tremor-free, and human hand precisions. Okay, we can make the precise surgeries with these Da Vinci surgical tools. Okay, the system provides 3-dimensional high definition magnified view to the surgical field, better than what we naked eye can see in an open surgery. The robotic instruments can rotate 540-degree, far beyond the range of human wrist. Okay? And the system automatically filter out natural hand tremors and ensuring that only clean intentional movement and transmit the instrument. The clinical benefits are significant. Patient experience smaller intrusion, less blood loss, reduced risk of infection, shorter hospital stays, and faster recovery compared to the traditional open surgery. So it is one of the major device that used for our healthcare system. And then next one is rehab robots. Okay, The rehab and assistive robots are used to help the patient to recover the lost function through intensive repetitive training. Okay, we have to train these robots to help or help to recover the patient lost functions or help their daily activity. Okay, so these are the robots are available for helping the patient for their rehab and assistive robots. Okay. The next one, hospital delivery robots. Okay, hospital delivery robots is are now in common in everywhere. Okay, we can deliver the medicine or the food items or whatever. Okay, these robots can we can give the patients proper time in medicine. Okay, so we arrange our program with automated logistic with healthcare facility. We can logistic or we can provide the medicine to the corresponding time in patient. Okay, so these are the three major robotics we are used in healthcare system: Da Vinci and surgical system, rehab and robot assistive robots, hospital delivery robots. Okay, so now we are going for tools framework platform for AI and robotics development for healthcare. Okay, what are the tools framework and AI platform tools used for robotic development in healthcare system? Okay, healthcare system we are using we are integrated with many of AI and robotic system. So how we can upgrade or how what are the tools that we are using currently? Okay, that we discuss in this session. Okay. These are the some of tools I listed. Okay, we will discuss one by one. Let us now look at each other tools greater than path, beginning with the Google Colab. Okay, the Google Colab is a free cloud-based Jupyter notebook environment provided by the Google. It allows to write and execute Python code directly into a web browser without installing anything in your local system. This is a game changer AI research because it removes the hardware barrier entirely. The real power of Colab is healthcare AI lies in its free access to GPU and TPU hardware. Training a deep learning model on a standard laptop might be taken hours or days. On Colab GPU runtime, the same model might train in minutes. This makes viable for researchers institutions do not have dedicated computer infrastructure. If you are a beginner, okay, if you're a beginner with to develop this type of AI based or ML software, the ML model, you can use go for Google Colab. Okay, Google Colab we can provide to develop the AI or machine learning model without any without our local machine or without the hardware barrier with us. Okay, so I will show you an example with medicine classification model in a Google Colab. Okay, so here you can see that I already coded this medicine image classification. Okay, so it's like here convolution neural network here, and I have a data set called data set Keras uh, data set from Keras, and it have the classes name tablet A, tablet B, and up to tablet J. And here we have to classify the medicine based on the image. Okay, so based on the image we are giving, the machine learning model predict what classes or the medicine the medicine might be which class can be we can label. Okay, so these are the labels for class name for I am using for the training the model. Okay, so after training I saved this model as medicine underscore model dot h5. Okay, here you can see that medicine underscore model dot h5. This is my model to used for predicting the medicine based on their image. Okay, so in here I created a prediction code. Okay, in here I'm uploaded the connected the medicine model classification model, and these are the classes names, class tablet A to tablet J. And here the uploading section, we can upload the image, medicine image, and predict. This model will predict which classes the medicine category include. Okay, so based on this classification, we can integrate these with a robotic system. Okay, send the robot medicine delivery picking or medicine picking robotic system. The robot can take action based on this machine model prediction output. Okay, here I created a condition that if the confidence rate is 0.7, greater than the 0.7, then the robot can take an action to predict that this medicine is correct. Okay, then you can based on this prediction value, the robot can take action to pick that medicine properly, or give to the corresponding patient, or give it to the corresponding section. Okay, so if the confidence level is less than 0.7, that means low confidence, then it can be near to human verification. Okay, so I added just a simple code here based on this confidence level. Okay, it will take an action. We can integrate this into a robotic system. The robotic system will act based on these rules. Okay, so I running this code. Okay, you can see that I'm choosing a file. Here I already have some medicinal image, so I am uploading this medicine. So you can see that the medicine is classified into tablet J, and with the 62.3% confidence. That means less than 0.7, then the low confidence. That means human verification is needed. So the robot can take directly, not directly take to the decision. The human verification is needed. Okay, then I'm uploading another image. Okay, yeah, that you can see that this medicine categories into tablet J with 80 to 83.3% confidence. That means robot can take an action to pick that tablet. Okay, so if you have really want to create this type of project, then you can label this to corresponding medicine like paracetamol, whatever the medicine classes, medicine names. We can label these names instead of this tablet A, tablet to J. Okay, so this is a simple machine learning model. If you are a beginner to study with AI and ML, okay, you can start with a machine learning, simple machine learning model with image classification or linear regression, whatever simple linear model. Okay, so based on this simple model, we can classify the medicine based on the image. Okay, so we have not installed any software here. We can use for Google Colab online. If you have a Gmail account or free Gmail account, you can go for free Google Colab. Okay, then next important one is Gemini robotic. Okay, Gemini Robotics, developed by Google DeepMind, represent one of the most exciting advances in robotic intelligence in recent years. Specifically, we are looking at Gemini Robotics ER 1.6, where ER stands for embodied reasoning. So, what is embodied reasoning? Okay, traditional AI model reasons in abstract. They process text or images or generate text or image inputs. Embodied reasoning goes one step further. Okay, it connects AI intelligence to physical body that must act in a real three-dimensional world. The model does not just understand the world, it must decide what to do in it physically. Okay. In previous slide, we have seen that Google Cloud based on the medicine classification. We are using medicine classification based on image. Okay, we are using a chat a like chat GPT or Google Gemini. It will create or generate text for us, but using Google Gemini robot, it one further step ahead. That means it not just creating or generating the test. It must act. It must connect. Uh, it must connect to the image, or it must connect to the what are the content we are given, or what are the inner details in the content we are given or instructions we are given, that will analyze by the robotic Gemini robots and create command or output based on that content. Okay, so I'm going to show you an example. Okay, in here I am using a surgical tools identifying and planning their arrangement. Okay, so in a hospital system, a robotic can use to identify the surgical tools and planning to arrange the tools in a proper section. Okay, so I am in this session I am inputting an image, that means image surgical tools with an image, and these Gemini robotics will go deeper in identify which other tools are here and how to place, and how a robotic system can process these planning and arrangement. Okay, planning and arrangement, and this can be done by the Gemini robotic system. Okay, so we are going for an example. So you can see that if you're in Google account, you can simply create a Gemini robotics account, and if I'm here already create an API key to connect my Gemini robotics 1.6, and here you can see that I already developed a coding section connected with the Gemini and inputting an image. Okay, here you can see that I am inputting an image called search.jpg. It's a surgical tool image. Okay, I will show you the image. Here you can see that the image. Okay, I'm going to upload this image to the Gemini robotics here, and it will identify what are the tools and how these can be arranged in a proper way by using the robotic system, and what are the commands to provide to the robotics to planning and arrangement these surgical tools. Okay, so you can see that I already uploaded the sur.jpg image. Okay, so based on this surgical image tools image, it will show what are the robotic system can be do to process and the planning their arrangement. Okay, you can see that. Okay, the uh, the robotic system. Okay, how to approach, how to clear, how the orientation, how the movement, what are the points, joints. Okay, what are the position to movement, and how to take and the proximity presentation and positions in relation clearance, how to lift, how what are the centimeter to lift, all the information or the instruction to the robot system is the created by the Gemini robotic here. So if you are integrated with this Gemini robotic here to a robotic system, we train with this system, we can use the robotic system can automatically get a commands to how this arrangement can be done. Okay, if you are in a surgical section, how to arrange these surgical tools, all the commands by directed to control by this Gemini. So this command will be generated by Gemini robotics, and it will integrate it to a robotic system. This can be done by simultaneously. Okay, so it is a best tool we have to use if you are using the robotic system to develop help for healthcare. Okay. Next, I am going for open AI models. Okay. OpenAI models, OpenAI models and agents has become one of the most widely integrated AI toolset in the real world, and healthcare robot is no exception. For our healthcare application, the key capability of OpenAI platform is multi-agent company means combining. Okay, a complex healthcare robotic task, say preparing a patient room for a new admission. It is not a single A problem. Okay, it requires vision model to assess the current state of the room, a language model to understand the preparation of the checklist, a planning model to generate a sequence of action, and motor control logic to execute each step. These are the four different A A connections that we need to work together seamlessly. Open agent framework that allows to developers to connect all these. We can see that we have different models to connect. If we are using a text based or image based or whatever, audio based or instructions command, whatever, we have plenty of models high here, so we can integrate our robotic system with these tools. We can create a huge means upgrade. We can create a another level of project. Why? Because if a robotic system not only depends on the single model or single section. Okay, if a robotic system using if we are suppose we are using the picking out system or picking a medicine, we have to use the vision and the robotic control system and the command system, so text control, whatever. So all these are integrated, we can use for open AI models. Okay, so now we are discussed about all the models and AI machine learning for the beginners. From Google Cloud, if you are a beginner, you can start with the basic machine learning algorithm or machine learning model to predict, classify medicine or whatever the healthcare system is used to classification or whatever the operation. Okay, Gemini robotics is used for a robotic system to understand via commands, or we are what are the instructions automatically generated to follow the robotic system, we can use for Gemini robotics. Okay, then OpenAI models to connect different models, so different scenario we are using, so we can connect different models, integrate different model to perform the task. Okay, now we are going for a tool called orange data mining. Okay, it is a tool that used for, if you are not familiar with the coding and that all for the AI and machine learning model, then for that users it is better option orange data mine. Orange data mine is an open source visual programming software suite used for data visualization, machine learning, and data analysis. Okay, so here I am going to discuss the or giving in the example diseases classification based on the symptoms. Okay, I am going to show you how the orange data mining used for a disease classification based on the symptoms. Okay, so it is a software. Okay, you can see that you can download from this site, orange data mining site. So I already downloaded and installed here. Okay, I will show you an disease classification example in the orange data mining. This is a platform where we can see that orange data mining dashboard. Okay, here you can see that uh, there are multiple fields, that data fields and transformation and visualization fields and model, different model here, and also the evaluation and prediction and all the visualization, everything is here. Okay, for the basic, we are a basic machine learning or a developer, you can use this as a not familiar with coding, then you can use with this, but you have to know the basic concept of AI and machine learning, that only you can use. Okay, here I'm going to show you. I'm here created a file widget. You can see that here a file widget. In file widget, I loaded a data set called diseases data set. In here I have already the data set called diseases data set. You can see that. Okay, in here the diseases classified these fever, cough, headache, body pain, etc., etc. Okay, so I am going to load this data set here. Okay, you can just simply drag this file widget here and double click, and you can upload the disease data set here. It is no coding is required here. So then we have to select the column. Next we have to select the column. If we have a machine learning model, creating a machine learning model, then we have variables called features and target. Okay, so features is the parameter where the target can predict. Okay, in here you can see that these are the features, and target is the diseases. Okay, so here you can see that selected disease. So based on the selected column, I selected for the diseases and features, target and features. Then I'm going for creating a machine learning model to feed this. Okay, so here you can see that different model have in here, logistic, linear, naive, and etc., etc. Okay, so I'm using here logistic regression. So you can see that just click that logistic regression widget, and you can see that there is connection. Okay, that's all. Okay, so I am already connected with the selected column data into the logistic regression. Okay, so you can see that logistic regression connected to this, and after this operation I'm going to save that model called test.pkcls. Okay, so I'm saving this model. Okay, after this operation I am connected to the save model option. You can see that the save model is here. Okay, then you can see the save model pkcls. Okay, so in here I saved the model. Then I'm going to next I'm going to use that model to predict the diseases based on the feature. Okay, again I am here to create a file widget and upload the data set for the prediction. Okay, for the prediction, and you can see that here again the saved model I'm loading here. It's called text.pkcls, and the prediction widget is called here. You can see that prediction widget. This prediction widget is to predict the diseases based on the features. Okay, you can see that all the given features, based on the all the given features, these all the fields can be predicted by to the predicted the corresponding diseases. Okay, you can see that the first is flu and second is flu and dengue, COVID-19, flu, dengue, etc., etc. Okay, so it is a simple application that to you can use to practice. Or if you are not familiar with the coding, you can practice with this. If you know about the basic understanding of the machine learning concept or machine learning model. Okay, so it is not a complex one. Okay, you can create or develop your project in here. Okay, this is, I think this is the simplest tool you can use to practice. Okay, machine learning models. Okay, then next I'm going for clinical NLP. Okay. Previously, we are discussed about the coding, simple AI, machine learning model, general robotics, and user interface, a GUI model for the data, AI, machine learning. Then in here, we are moving to the um, next higher section. It's called transformers. We can in hospitals or doctors, insurance companies and researchers use ICD coding for billing. Okay, so the medical records and health statistics. So we have to use that patient details to identify that is which is ICD code can be classified. So the researchers or billing section or medical or insurance companies can easily use that code for their processing. So I am in here, I am going to show you a clinical NLP, or means transformer or bio bird, combination of bio bird. The patient summary or the patient some details. With the patient details, it will classify into the corresponding, it will classify what are the ICD code for the each users. So I will show you how this working. If your patient called, I will show you an example. That's Rajan Pillai, 64 age patient. You can see that these are the discharge summary of a patient and chief complaint, key clinical terms, diagnosis listed, drug names, follow-up content. Okay, based on this discharge summary, we can we can analyze what ICD 10 codes for these patients are. So it can be used for the insurance company or hospital bill management system, whatever. Okay. Mm. So I also developed a coding section for this section, but you can see that the coding ICD codes for basic ICD codes and how these can be done based on this bird. Okay. So first, the word piece tokenization. Okay, then raw text is about 600 words, and it's split into sub word tokens and converted into numerical IDs. Okay, and parallel to exactly 256 token. Then next step two, bio BERT encoder. In BioBot encoder, the 12-layer transform model with 110 million parameter pertained on PubMed and clinical text process these 256 token in parallel. Each token attend to every other token through the self-attention mechanism, producing a 768 dimensional contextual vector for each tokens. Then next step, extract the CLS token, special summary token, which is represent the full meaning, the entire clinical note on in 768 dimensional vector. Okay. Then next step, linearly classification head. Then sigma we used to activation function, sigmoid function, and at last we have seen that the prediction can be done based on this problem value. And at last we have to see that ICD code based for this patient can be seen. Okay. The next one, ICU readmission prediction using XGBoost and SHAP on Mimic IV. Okay. So in here, what is the problem is the problem is to predict whether a patient will be readmitted to ICU using a clinical data. Based on the clinical data, we have to identify a patient is what a chance to readmit the patient into ICU. Okay, so based on we have a sample data set here, mimic IV for mimic IV data set, and also combine the tools XGBoost and Sharp. Okay, we have to predict the patient how what a chance to patient readmit into the ICU. Okay, so these are the sample workflow. Initially, data source, data extraction, processing, feature set prediction, then model training, prediction, then explanatory clinical use. Okay, so I will show you how this working. You can see that I'm here uploading a data set called Mimic IV ICU readmission. It combined with the data, um, the patient heartbeat, HSPB, or all the details of the patient here, sample data. Okay, based on this value, we have to train to a model and predict that predict a user will readmit into the ICU or not. Okay, so these are the data for I'm using for training the model. Okay, you can see that if the value the target is 1, that means the prediction is true, that means the patient will readmit to the ICU. Okay, 0 means the patient will not admit to the ICU. Okay, so here I am training a model and also providing a new patient data. Okay, here I am providing a new patient data here to predict this patient is readmitted to the ICU or not. Okay, so you can see that the readmission prediction for this patient is 1. That means it's true, the patient will readmit to the ICU. Okay, with the probability of 0.86. Okay, so you can see that AI and machine learning models or AI, artificial intelligence will predict the readmission of a patient in future. We are based on their data. Okay, so if in healthcare system, it will help to identify the condition of a patient. The patient when will admit to the ICU based on their continuous. We have to integrate with some wearable gadgets, like we can monitor the health health conditions of patient regularly or continuously. We have to feed that data into this model. Okay, then this model will analyze when the patient will admit to the ICU or what are the effects affecting the patient health conditions. Okay, we have to analyze based on this data or with this model. Okay, okay. So moving to MATLAB, in here previously we are looking upon OpenAI model or machine learning model, Gemini robotics and Orange clinical and XGBoost and Sharp. All these are for the software based means a models to predict the healthcare system or healthcare application. And here we are using for we are going for MATLAB for the robotic system. The robotic systems, how to simulate our robotic system for healthcare, and what are the tools used for that. The first one is the MATLAB. The MATLAB provide a robotic system toolbox, provides tools and algorithm for designing, simulating, testing, and deploying the manipulator and the mobile robotic application. Okay, so using MATLAB, you can develop plenty of application in AI, ML, robotics, etc. Okay, So okay, you can download the MATLAB from MathWorks site. Okay, MATLAB MathWorks. I already downloaded and installed. I will show you an example of how this robotic system or robotic simulation can be done using the MATLAB. Okay, here I created a code for the 2D, two-dimensional robotic arm simulation. Okay, so this arm simulation is, we have already discussed the robotics parameters and the manipulators. Okay, previously, based on that understanding, we have to create a two-dimensional manipulator arm. Okay, so I will show you that. You can see that the movement, okay, of the two-dimensional arm. Okay, and the next one, a robotic robotic arm for welding process. Okay, okay. If you have to if you're customizing these codes or simulation into surgery section, okay, we have to simulate the environment for the surgical section in here with the robotic arm simulation. Okay, so so we can know that what are the issues or what are the problems that arise in actual environment. We can simulate this in MATLAB here and the robotics arm, so we can easily find the errors and whatever the defects using this arm or the operation performance. Okay, I will also show you that another example. It's a robotic object picking arm. Based on this object, it will classify into the corresponding position. It will pick, the robotic arm will pick the object and identifying the object and placing the corresponding section. So if you are using here, if you, this concept using to healthcare, if you are picking the corresponding robotic arm for the medicinal picking, okay, or correspond, so we have to train these to visual image data, what are the medicine, then the medicine will pick by this robotic arm and play where to place. The place have been trained, also the place have been trained, then the robotic arm will perform the pick and place the medicine in the corresponding place section. Okay, so MATLAB providing you the better simulation environment for the robotic simulation. So it will provide, give you large development in means large development of the robotic simulation environment by using the robotic system toolkit. Okay, the next I'm going for in MATLAB, you can see that is a single means a personal development or personal project. If you're going for an industry or organization, completely organized, means if you're going for the organization to develop or complete operation in automation, then we are going for NVIDIA Clara. Okay, so NVIDIA Clara is providing for AI for personalized healthcare for hospital, complete automation process of a hospital we can use for NVIDIA Clara. So it enables developers and researchers to build and train, deploy AI models for tasks like diagnosing image. It's especially for the hospital healthcare. It's diagnosing image, smart hospital monitoring, and accelerating drug simulation, etc., etc. You can see that NVIDIA Clara Horoscon used for scanning the our multi-organ rendering system. Okay, so it's used to render the our multi organs using the NVIDIA Clara Horoscon. So NVIDIA Clara providing different inside, it have different framework for means framework for developing and deploying the models or developing the application. For example, if you're hospital monitoring, we have another framework, or if you are used for robotic simulation and another one, and if you are only for the pharmaceutical and medical imaging system or patient monitoring, and it will the NVIDIA Clara provide for all these to a single bundle or different, okay, I mean separately. The first one is BioNemo. Okay. BioNemo is NVIDIA's generative AI platform for digital biology, especially for the design and simulation of biological molecules, include proteins, DNA, RNA, and small molecules drug components. Traditional drug discovery follows slow, expensive path. A researcher hypothesizes a drug target, usually a protein involved in a disease pathway, and then searches through libraries or existing compounds to find one that might bind to inhibit the target. The process can be take years or cost hundreds of millions of dollars with very high failure rate. BioNemo accelerate and transform this process using generative AI. Instead of searching through existing molecules, BioNemo generates new molecules, novel protein sequence, antibody structures, and small molecules that are predicted to interact with a specific target. This AI-generated candidate can then be validated in computational simulation before any laboratory works begin. Okay, we can actually we can simulate this environment we are before we are going to the real-time environment. Okay, so we have to save the cost and time and the right also. Okay, the key model with the BioNome include ESM2 for the protein language model, AlphaFold integration for protein structure prediction, and MolMIM for generating small molecule with desirable properties. Okay. In this context of healthcare robotics, BioNemo designed to drugs compound could be manufactured and dispensed by the robotic pharmacy system, creating a seamless pipeline from AI-designed drug to patient-administered dose, a vision of fully integrated intelligent hospitals of the future. The code base is open source and available at GitHub. Okay, I will show you that what are the libraries used in BioNemo. Okay. You can see that there are plenty of repositories here for the proteins or the biological molecules. We can try and using these molecules data to develop our project. Next, I'm going for Nematron. Okay, so Nematron is a NVIDIA family of large language model optimized for enterprise and domain-specific application. In the context of healthcare AI, Nematron is specially trained and fine-tuned on medical domain data, clinical notes, medical literature, database, and diagnosis guidelines to give healthcare AI system deep, accurate medical language understanding. Why do healthcare robots need a language model? Why do healthcare robots need a language model? Because the real world of clinical care runs on language. Doctor orders are written in free text. Patient history are documented in native form. Drug interaction warning are communicated verbally. A healthcare robot that cannot be interpreted naturally clinical language is severely limited in how intelligently it can be function a hospital environment. Nematrons enable healthcare robots to understand context specific commands. Okay, no just move to room number 4, but take the IV back to the patient in the room number 4 who is post-operative day 2 from post-operative day 2 from cardiac bypasses. So it enables not only the instruction to move, it will also uh, give additional data to the operation. So it enables a real-time interpretation interpretation of verbal handover instructions from nurses, automated extraction of actionable items from the physician notes or general clinical summaries. A robot can use adaptive behavior. So our notes, hospital doctor's note or nurse note or whatever the notes given, it will automatically analyze and perform based on that data. Okay, Nematron also designed to be a fine tunable. Institution can take the base model and fine tune their own clinical documentation to adapt it to their specific terminology workflows for patient population. This capability is available through NVIDIA AI Foundation platform at NVIDIA Nematron section. Okay, I will show you the Nematron section also. You can see that Nematron have different models. Okay, Nematron Nano 30 3B for coding reasoning method context, and next Nematron 3 Nano Omni 30 and Nematron 3 Super 1, Nematron Ultra and Pass, Nematron Drag Speech, and Nematron Safety. Okay, yep, you can use for your project or organization to develop your own model or customize or fine tuning your model. Okay. Next, I am going for Monai. Okay, so Monai is an open medical imaging AI framework. It is a very, very important framework that we can integrate with the local system or local software or hospitals management, our imaging sections, means our scanning, hospital scanning. All these can be integrated with this Monai AI. Monai AI imaging framework. Okay, so Mona is an open source community driven framework purpose to build deep learning model in medical imaging, and it was developed also by the NVIDIA collaboration. And Mona is built on top of PyTorch, and it provides medical imaging specific components that are not available in generic deep learning libraries. Okay, these include medical image data loaders that handle DIGOM and FT format data. Okay, especially transformers designed for volumetric 3D medical images, losses functions optimized for highly imbalanced medical segmentation tasks, and evaluation metrics specific to medical imaging analyze the die score and hands off distance. The primary application of MONA in healthcare robotic is real-time organ and tissue segmentation. Okay, we can segment the organs or our internal organs, or we can analyze the organs by using the Mona AI. We have the plenty of library of DCOM. I mean, that means library for the medical imaging data set. Okay, so we can use for the project, or we can use the analyze or studies. Okay, we can, or the for the researchers you can use these library DCOM libraries for analyzing. It will automatically analyze what are the segments or the points we have to pointing, or it will analyze the image, the scanning image, and give us a total summary of detailed description of the scanning result. Okay, so I will show you an example. Before that, I will open a Monai details. Okay, so you can see that here Monai have plenty of research ready labor softwares and libraries, frameworks, etc. We can customize or monite label. We can deploy whatever operation we are using the medical imaging system or healthcare imaging system. We can efficiently use this Mona A platform framework for our accurate data analysis. Okay. So I will show you an example. Before that, I will introduce another tool called 3D Slicer. Okay, the 3D Slicer is an open means, or it's a tool we can we can show that we can view that the all the decom images. That means our scanning images, and if you are connected with this 3D slicer to Monet label or Monet framework, this AI will enhance enhance the details of these images or decom images with this 3D slicer. Okay, so I already download the 3D slicer here. I will show you that the 3D slicer. You can see that 3D slicer here. Okay, on if you in this we have plenty of libraries here. Okay, I will show you that here. You can see that active learning section we have the mono a label is here. Okay, I already installed this plugin here, mono a plugin here. Okay, if you have purchased or developed a mono AI framework, okay, a framework, and it and created a host or network, then you can connect your network to this mono label server. Okay, so if you are a hospital network connected with this mono label network framework, or your software or scanning software, whatever, it will analyze this, it will automatically analyze the images of the scanning or the scanning result of any organ result, or the segmentation of these organs will automatically analyze by this mono a label server. Okay, means AI. Okay, the based on this mono AI label server, it will show you the what are the segment points, all this. Okay, so if you are interested in connecting with the mono AI label or using for your organization, then you have to create a mono AI network for that, then connect to this 3D slicer. So I will show you a sample image that scanning image for to how this 3D slicer can be used. Okay, so initially I have already downloaded the data, decom, that means the medical image scanning details. Okay, so you can see that the 3D slicer will show you every single data we are uploading, or the scanning different sections of scanning details. Okay, it have the data. I uploaded the folder. You can see that. I will show you series. Here I have the 5 data of the scanning images. You can see that I already I uploaded all that. You can see that all individuals design or data of this scan result can be, you can see that if you are integrated with mono a label here, mono label to connect your server, mono label server to here, then you can this mono label automatically analyze these scanning details and give us detailed description of these scanning details. Okay, so combining these 3D slicer with mono eye, combining this 3D slicer with mono eye, we have to visualize the data, and also we have to show the how what are the each point in the scanning result maybe predicted by using this mono AI. Okay, I will here you can see that a sample example here connected with the mono AI label of the scanning images. Okay, so it will pointing out the what are the sections. You can see that what are the sections that will be affecting, or what are the means issue for the patient, what are the section. You can see that it will pointing out the region based on the A analysis, mono A analysis. You can see that these 3 points can be identified by using the mono A label. Okay, so it is much more efficient. You can combine this mono A label with the 3D slicer. Okay, if you are in a healthcare system, you can use this system, or if you are developing medical means healthcare project, and you can analyze the medical images. Also you can use this mono A label plus 3D slicer. Okay. Next, I'm going for OHIF viewer web-based. Okay. If you don't want to install heavy software, the Open Health Imaging Foundation viewer runs completely in web browser. It integrated directly with AI inference engine to overlay machine learning prediction on standard medical decom images. Okay, so I will show you why the OHIF viewer. Okay, it will have the plenty of decom data, and we can analyze by scrolling. And if you are able to if you are thorough knowledge about the AI and with integration, you can also integrate the OHIF viewer with your AI model to identify and predict the data of the scan decom images. Okay, so I will show you the OHIF viewer. Okay, you can see that OHIF viewer. Okay, and here is a site ohif.org. Okay, from this site can click the try now option, and it will give you the plenty of scan details of the patients. Okay, here I will show you an example CT neck soft tissue. Okay, here you can see that basic viewer and segmentation, or also the segmentation. Okay, basic viewer, you can see that the movement here, it have the data 295 data is here, means decom images are here to analyze or study, or researchers can study the result or scanning details. Okay, I will show you the movement, how this can be moving. You can see that the changes. Okay, so if you are integrated with this, it is open source. Okay, if you are integrated with this OHIF to your AI, then you can analyze or study, or can operate this imaging data to a project or your uh, training purpose. Okay, and also I will show you some example to download decom data for your project. First one is a decom library. It have the sum of data about the modalities of the scanning data of eye and neck and stomach, etc., etc., and teeth, etc. So the library having some data of decom image, you can download and use for your project. And also another site called Cancer Imaging Archive. In here also you can see the different decom images for the different cancer types. Okay, you can download it from here, the decom images for your project. It's MRI, CT, whatever, all the data can be here. Okay, you can use for your project or development section. Okay, first one is decom library, and the second one is cancer imaging archive. Okay, the next one is Act for healthcare. It is also one of the NVIDIA component, application healthcare component, and it is used for robotic simulation platform designed especially for the healthcare domain. It is built on the top of the NVIDIA Omnis platform and photorealistic, physically accurate 3D simulation environment powered by the universal scene description, or USD. The core value of proposition of Isaac for healthcare is risk-free validation. Deploying a robot in a real hospital environment, particularly in high-risk area like ICU, operation theater, and emergency department, carries inherent risk. So a robot that behave unexpectedly could injure a patient, disrupt a time critical procedure, or create a hazardous situation. Physical testing in real hospital is expensive and logically complex and ethically constrained. So in that concern, we are used for ISAC for healthcare. The ISAC for healthcare solves this by creating photorealistic virtual hospital where the robot can test thousands of scenarios that would be impractical or impossible to recreate physically. Okay, and want to see how a delivery robot navigates crowded ward during uh, code blue. Simulate it. Want to test how a surgical robot respond to unexpected patient movement. Simulate it. Want to train an AI model to recognize patient files, camera data from 550 different camera position, generate the training data in simulation. This platform physically accurate simulation of a robotic dynamics, realistically patient and staff hours, natural movement patterns, simulate sensors data include LiDARs, RGB cameras, force sensors, etc., etc. And Isaac Healthcare for healthcare represent the state of art in what the industry calling sim to real transfer, developing and validation robotic behavior in a simulation environment. Okay, so this project is accessible at Isaac Healthcare at .github.io. Okay, you can see that Isaac for healthcare github.io. Okay, it will provide a complete hospital automation simulation. Okay, if you're developing a project like that, full automation robotics or simulation AI whatever, or the hospital simulation automation process we can use to simulate by using the Isaac for healthcare system by NVIDIA. Okay, the next one, two important one is the holoscan SDK and Parabix. A holoscan for the physical AI sensor processing, it will give us the real time, means it will create a hologram of a multi-organ system, or generating or rendering, we can render the multi-organ system by using the holoscan. And also the Parabricks used for it rare diseases, means it will used for the cancer and rare diseases and critical care population. For the that type of project, that type of a model, that type of operation that we can use for Parabics. Okay, these are the frameworks or tools, yeah, that I used is provided by the NVIDIA platform under the NVIDIA Clara. Okay, so NVIDIA Clara and BioNemo, Nematron Monai, and Isaac for healthcare holoscan and private. That these are told by the NVIDIA. Okay, so if you are an organization, especially combine all these process or all this automation, you can give done with a single package. You can go for the NVIDIA Clara. Okay, the next important one is webhooks. Okay, so we are going to develop a robotic simulation by using the webhook. Okay, webhook is an open source multi-platform desktop application, and it provides a complete development environment to model and program simulate robotic system. Okay, so I will show you what are the just a simple simulation of robotic system. Okay, I will show you an example. Okay, you can download the webboots from the cyberrobotics site here. Okay, and install. I already install the webboots. Okay, you can see that this is the interface of webboots. Okay, in here the plenty of the built-in libraries here for the robotic simulation. It has some basic robotic system like Frank Chemica, Universal Robot, and ClearPath. I will show you one by one. Okay, the first one is Kukua Robotic. This is used for surgery. If we can develop or customize this Kukua robot, then we can use for the surgery assistant and precision medicine handling. Okay, so I will show you that Kukua. Okay, you can see that here robotic samples are here, and here Kukua. You can see that. Okay. Here, this robot we can use it for surgical assistant or precision medical handling. Okay. Then next one is Franca emica. Okay. Franca emica. I will show you the Franca emica. So we can see that this robot can be used for the lab automation purpose or medicine picking services. Okay, so if you are a developer or you can familiar with coding, you can customize this code. Okay, I will show you that. Okay. Can customize this code. If you are familiar with the robotic parameter also, you can customize the parameter values also here. Okay, your basic knowledge of C programming language, then you can develop or customize these all the parameters of robotic simulation. Here you can see that all the details, all the joints or the robotics components have been here. Okay, and here webhooks all we have plenty of robotic simulation libraries here. Okay, Franca Amica and Kukua. And the next one, universal robotic robots for the pharmacy automation. And also the clear path for the hospital delivery. Okay, pharmacy automation and hospital delivery. I will show universal robot also. Universal robots. Just a minute. Pharmacy automation. Okay, we can use the universal robotics section. Okay, this simulation environment can be used. If you are okay with the simulation environment, we can go for the real-time practical and development for this robotic system. Okay. The next one, Copilot sim. Okay, if you are not familiar with the coding for the robotic simulation, then the better option is the Copilot sim. Copilot sim is a powerful robotic simulator that allows you to design and test complex automation system in realistic 3D environment. Okay, in here you can also see that Kuka robot and universal robot and ABB robots are in here. I will show you how this robot can be worked without coding. Okay, you can download this Copilot sim from the site. Copilot robots. Okay, and here I show you an example. Okay, here you can see that it have plenty of library with the mobile and non-mobile robots. Okay, mobile and non-mobile robots. Here, mobile robots are the AZM, Kukua, and Kukua yogurt. I will show you Kukua yogurt first. Okay. It is a mobile type robot, medicine delivery, pickling, autonomous service. We can use that. Okay. If you want to customize this robot, you can customize just by clicking, adding, just drag and dropping. You can, I will show you that you can add the parameters or the camera, sensors, vision, proximity, force, whatever you want to customize, add. You can just click, drag and drop, or by click by adding. Okay, there is no need for the coding. Yeah, okay, with coding, you can also coding the customize the robot using coding. Okay, and next one. Next one, I will show you a UR5 robot, and it's a non-mobile robot. UR5. It is also the medicine picking and pharmacy automation. Okay, we can also add the sensors and components, extra components, or customize by adding wherever you want. Okay, you can also the link joins and customize the join or the degree of freedoms or whatever the we have already discussed in the robotic parameter section. Okay, also you have to customize the this section, adding some new components. Okay, so if you are not familiar with the coding, you can go for this Copilius sim robotic simulation, and it has also the plenty of library software simulation, robotic simulation libraries here. Okay. Okay. Then we go for the what are the future robotics trends in healthcare in India. Okay, India have over 300 plus surgical robots and 660,000 plus robotic surgery per year. And also we are moving to integrate with AI robotics to enable our smart diagnosis, automation, hospital workflow, real-time decision making. And also we have to AI plus IoT, creating intelligent connected hospital also for the supporting industry 4.0 healthcare. Okay, and you can see that we are actually we are moving towards to the AI and robotics to our hospital or healthcare system. Okay, and that's all for today. And the summary means we have already discussed about different tools and basic laws and basic components, tools, and also different types of healthcare systems and tools, different types of tools, platforms, and frameworks used for healthcare, and different frameworks, tools, and simulation software. All we are discussed. So, if you have any doubt, I am always here, and that's all for today. Thank you.
Thank you, sir. We will now proceed to the question